everyone, this is Miss Afric. Today we are going to go through how to graph a log function. So we've already graphed exponentials, which remember are the inverse of a log. So now we're going to practice graphing log functions. Now the graphs of log functions come directly from an exponential graph. So we're going to start by reminding ourselves how we graph an exponential function. Alright, so this right here, that is an exponential function because the variable is in the exponent. Alright, so write that down if you think you need to remember how to tell it's an exponential. Alright, remember with exponential functions, our key points are 0, 1, and 1, b. But then we have to keep in mind any transformations. Now this one is the parent function. There's no transformations. So that means that our key points are going to be 0, 1, and our base here is 2, so that would be 1, 2. Okay, then our asymptote starts as y equals 0, and if there are transformations, we would adjust. But since there are no transformations, this would be y equals 0. Alright, so if we graph it, let's see, y equals 0 is this line right here. 0, 1, and 1, 2. So it would look like this right here. Oops, let's try that again. Alright, something like that. Okay, well, now it says find the inverse of the function you graphed above. I know we haven't done this in a while, but let's remind ourselves. Okay, finding the inverse means we switch x and y, and then solve for y. So those are the two steps we're going to do. So our original equation was y equals 2 to the x. So if I want to find the inverse, I'm going to first switch x and y, x equals 2 to the y, and then I'm going to solve for y. Now, we haven't exactly learned how to solve this equation yet, but we have learned how to rewrite it. So rewriting it is something that will help me solve for y. Alright, so to rewrite this, I'm going to use the log. My base is the base of my exponential, so that would be base 2. Remember, a logarithm equals the exponent, so that would equal y. And then the given number, x in this case, will go right inside our log. So it's log base 2 of x equals y. Alright, so this is the inverse right here. Notice how the inverse is the exact same base, but with a log function. Interesting, isn't it? Not only that, but inverses mean you just switch x and y. So the reason why I wanted to do that real quick is so that you could see how the graphs of these are going to relate. Remember how in an exponential function, these were my key points right here? These are the x's and these are the y's. Well, to get the log function, we're just going to switch x and y, because that's what we do for inverses. Same thing for the the asymptote, sorry. Alright, the asymptote was y equals 0 for an exponential function. Well, since for the inverse we switch x and y, for a log it's going to be x equals 0. So hopefully you can kind of see why this idea of them being inverses is important. Alright, so the graphs of a log function, again, this is the parent function with just the base, no transformations, and our key points are 1, 0, and b, 1. Notice how that's the same key points as an exponential, but we switched x and y. That's because they're inverses. So that works for any function that's inverses. Alright, same thing with our asymptote. So before we had a horizontal one, which was y equals 0. Now it's vertical and it's x equals 0, which is the same thing. We just switched x and y. Alright, now if I have transformations, so mostly we're just going to focus on our horizontal shift and our vertical shift for these, since they're brand new graphs. Alright, if I have transformations, then that will definitely impact my key points in my asymptote. Alright, so I know this looks a little complicated, but it's actually going to be really similar to what we did with exponential graphs. So let's try a couple. Alright, this says graph the following equations and show your key points and asymptote, then state the domain and range. So just like with an exponential function, we're going to figure out our parent function first. And our parent function should just be with the base and our x. No extra pieces. So in this, it'll just be log base 3 of x. Alright, now the parent function's key points, remember it's the same as an exponential, but we switch x and y. So before it was 0, 1. Well, I'm going to switch them. So it'll be 1, 0. Same thing for my second point. With an exponential, it was 1, b. We're going to switch them. So now it's going to be b, which in this case is 3, 1. Okay, so again, remember, those are our key points for these. All we did was switch, there we go, switch x's and y's from when we graphed exponential functions. All right, then the asymptote, remember, before it was y equals 0, so now it'll be x equals 0. So our asymptote is x equals 0. Okay, now we just have to figure out our transformations. Luckily, there's only one here, all right, and that's a shift left 2. So when I create my table, I'm going to do x minus 2, and y is going to stay the same. So my key points, well, I'm going to do the x, I'm going to subtract 2, so that would be 1 minus 2 is -1, but y stays the same. And same with my other key point, 3 minus 2 is 1, but y stays the same. Okay, and if I shift left 2, that is going to change my asymptote, because my asymptote is x equals 0. So I have to do 0 minus 2, which would be x equals -2. So my key points became -1, 0 from right here, and 1, 1 from right below it. All right, then my asymptote is x equals -2. So let's try graphing it. All right, x equals -2 is a vertical line where x is -2. I have the point -1, 0 and 1, 1. All right, and for these graphs, again, they're still going to approach our asymptote. Oops, let's try that again. Just like they did before, but now they're just going to kind of go out. And they should be a little bit curved, so something more like that. And that's our log graph. All right, the last two pieces are domain and range. Well, this is going to be a little different too. But again, it's the same idea. Just switch x and y. So think back to those exponential graphs. Do you remember how the domain was all reals and the range had a restriction? Well, now we're going to switch that around. So for these, our range is all reals because look, it's going all the way down and all the way up. So our range is all reals, but our domain is going to have a restriction, and it's based on our asymptote. All right, x's have to stay to the right of -2, so that means x has to be greater than -2. All right, not so bad, right? So it should be very familiar because it should be just like graphing exponential functions. We're just switching x's and y's. All right, let's try one more, letter B. So in letter B, again, same thing. I'm going to start with my parent function. So that would be y equals log base 2 of x. So my key points, remember, we switch it, so it's 1, 0, and our base is 2, so 2, 1. And then our asymptote starts out as x equals 0. Okay, now I just have to create my table. That was bad. Let's try again. There we go. So I take a look at my horizontal transformation. That's right 5. So that would be x plus 5. And my vertical transformation, that's up 1. So that would be y plus 1. So for my points, 1, 0 turns into 1 plus 5, so 6, 0 plus 1, which is 1. And then 2, 1 would turn into 7, because 2 plus 5 is 7, 2, because 1 plus 1 is 2. And again, my asymptote, since it's x equals 0, only is affected by these x's, x plus 5, so my new asymptote is x equals 5. So my key points are 6, 1, and 7, 2. And my asymptote is x equals 5. So let's try drawing it. X equals 5, there's my asymptote, 6, 1, and 7, 2. Alright, so again, to draw this, I'm hugging my asymptote, and then we're just curving out. Alright, now once again, look at how it's going down and up. That means the y's are all covered, so my range is all reals. But my domain is restricted because of this vertical asymptote here. Alright, x has to be to the right of 5, so I would say x is greater than 5. And that's it. Alright, we're going to save these last two for class tomorrow, but feel free to try them on your own if you'd like. Otherwise, write down any questions. Maybe try re-watching if you still have a lot of questions. But otherwise, just write them down. We'll talk about it in class tomorrow. See ya!